Okay, so hello everybody. This is Agi Tutorials on physics, and this is going to be about motion. So there are some important terms that we're learning, and some of them are speed, velocity, and acceleration. And so these all have different meanings, and except for these. So speed and velocity are somewhat similar, but they are still different. And so this is how they're different. Speed and velocity have some similarities, but they also have some differences. And so speed and velocity. Speed is basically velocity, but without direction. So, for example, you're in a car and you're going at 60 kilometers per hour, and that would be speed. Velocity, on the other hand, could still be 60 kilometers per hour, but it would be 60 kilometers per hour north or south or any other direction. So that's basically the difference between speed and velocity. Speed doesn't have direction and velocity does. Other than that, they're the same. Then you have two types of graphs: position time graphs and velocity time graphs. Okay, so the difference between position time graphs and velocity time graphs is, well, in the name of them. This one talks about position, and this one talks about velocity. So if we were to draw a position time graph, like this, what would go on this axis? This axis would have the time, and so in this case we can do time in seconds. So what would go on the other axis? In this case, it can be meters because we're doing position. So you can do X or right position, anything that represents position. And so this can be 0, and let's mark the graph. Okay, so now imagine you start at position 0, at time 0. So you're just standing there. So we can plot a point. And then after 10 seconds, you move 20 meters. And so you're here. And then after 20 seconds, you're at 40 meters. And so then we can draw a line through those points, and this would be how our position time graph looks like. And so to read this, you could look at the seconds, which is on the x-axis, and then at the position, which is on the y-axis. And so if you wanted to know where you were at 20 seconds, for example, you could look here and then go up, and roughly about here, you have 40. So at 20 seconds, you are at 40 meters. Okay, so now for the velocity time graph. We can still use this position time graph to help create the velocity time graph. So we do the same thing, we draw the graph, and here we can still have time, still in seconds, but over here, instead of having position, we're going to have velocity. So we can write velocity in meters per second, since that's the measurements we're using here. And then, or we could also write velocity like this. And this is how velocity is written because something that people might think velocity and speed are the same because they're represented by similar letters. Speed is represented by a v, and velocity is represented also by a v, but with an arrow on top. And this symbolizes the direction because it has an arrow. And so that's why we can write it with an arrow here. So let's also mark this graph. So now, we need to basically graph the velocity of this object. And so, if we look over here on the position time graph, we can see that the line is going up, away from the 0, and it's above the x-axis. And so, we can see that the position is increasing, and it's positive. This means that our velocity is also going to be positive. And so, if we look over here, for example, where we have this marked, we know that over here, we know that at time 20 seconds, you were at position 40 meters. And so, basically, to find the speed in this graph, or the velocity, to find the speed of this position time graph, we can look at a certain point in time, such as this one. Because the line is straight, this tells us that because the line is straight, this tells us that the speed because the line is straight, this tells us that the speed is not changing. It's always the same. So here we know that at 20 seconds, it was at 40 meters. So how do we find the slope? One important thing to note about this position time graph is that we can find the slope, we can find the speed of this object or person by looking at the slope. So let's look at this point over here and then this point over here. So how do we find slope? Well, slope is basically the rate of change, and you could represent it by writing m equals y1 minus y2 over x1 minus x2. And basically, what this means is that this is a point, and this is another point here. And basically, you're trying to find, like, what is the rate of change for a line between these 2 points. And so, in this case, our 2 points are this one and this one. And so, we can replace the coordinates for the slope equation, and then we get m equals m equals m equals 40 minus 20, and we get this because this is the 40, it's the y-coordinate of this point, and this is the 20, it's the y-coordinate of this point. And then we can divide that by 20, and then minus 10. And this is because this 10 is the x-coordinate for this point, and this 20 is the x-coordinate for this point. And so, if we solve this, we get 20 over 10. And then we can simplify that to 2. And so now, we know the slope is 2. And because the slope in a position time graph represents the speed, we know that this means 2 something per something. And in this case, what is the unit of time? Seconds. And so instead of this nothing, we're writing seconds. And then what is the unit for position? Meters. And so this means that instead of this nothing, we can write meters. Now we know that our speed is this. Okay, so now you might still be a little bit confused about the difference between speed and velocity, so here's something that you need to know in order to not be so confused. To find speed, basically you need to do the distance traveled by an object or a person divided by time. This is speed. or just the v. Now, to find velocity, which is this, or velocity, you need to do displacement divided by time. Now, this might be a little confusing because you might not know what the difference between distance and displacement is. But let me tell you, it might look complicated, but the difference is actually easy to... The difference between distance and displacement is that distance... The difference between distance and displacement can be discovered from a diagram or a drawing. So imagine you start over here. This is your start point. And then you go all the way here, then here, then here, and then over here. And this is where you finish. What is your distance? In this case, your distance would be this path all the way here. So this is your distance. And so what would the displacement be? Well, do you notice how these 2 points are close? Well, these 2 points have a distance between them, right? And so that distance, this bit over here, is the displacement. Basically, the displacement is the least possible distance between 2 points, and the distance is the actual distance between those points, as in how far did you actually go to get to that point. So another way you can imagine this is someone is walking. And so this is position 0. This is 1. This is 2, and let's do meters, just to make things easier. Okay, so you're here. Then, suddenly, you move 2 steps forward. So now, you're here. So this is point A, and this can be point B. And then, you decide that you want to go back, and so you go back here. And then, you're over here. And this can be point C. So now, let's think. This is your starting point, right? And this is your end point. So how far away are you now from where you started? If you're at 1 meter and you started at 0, what is the distance between this? The distance is 1 meter. And so, well, technically it's not the distance, it's the displacement, because it's the shortest distance between your start point and your end point. Now, to find the actual distance, we need to look at the steps you took to get to where you ended up. So here you went from 0 to 2 meters. So this distance from 0 to 2 meters is 2 meters. And then you went from 2 meters back to 1 meter. And so from 2 to 1 is a 1 meter distance. And so what do you have if you add these two together? 3 meters. And so this is your distance. So, now that you hopefully know more about distance and displacement, let's go back to our position time graphs and velocity time graphs. So, we were going to plot the velocity time graph, and so we need to know the velocity. Since we know that this velocity is positive, we can graph it in the positive quadrant, sort of, which is this one. Below that would have negative numbers for the velocity, but we don't have a negative velocity, so we will not be using this part. We'll only be using the part above. So, we figured out before that 2 meters per second, over here, is the speed. So, we know that now the velocity has to be that, but with direction. So let's imagine that this is position and it's north, for example. So you're moving 40 meters north. And so our velocity would be 2 meters per second north. So how do we graph that? Okay, so what is your velocity at the beginning? Right over here in the position time graph. You're at 0 seconds and you haven't moved. So that means you don't have a velocity because you're not moving. And then, what happens to your velocity? Well, as we said before, the line on this position time graph is straight, which means that the velocity and speed are not changing. It's a constant number throughout the whole trip. And so, this number that we have, 2 meters per second north, is always going to remain 2 meters per second north. So, to graph the velocity, we need to look at over here, the position time graph. We know that to graph the velocity, we need to look at the speed and the velocity. To graph the velocity, we can look at this number, 2 meters per second north, and then see if it changes throughout the trip or not. If you look at the position time graph, it's a straight line, which means that the speed and velocity are not changing. They're constant throughout the whole trip, which means that if we know what it is, 2 meters per second north, it's always going to remain 2 meters per second north. That means that we can graph it, and the velocity will always be 2 meters per second north. So, at 0 seconds, what is the velocity? 2 meters per second north. So we would graph that over here. And then at 10 seconds, what's the velocity? Well, the line is still straight. It hasn't changed direction. It continues moving forward, which means that it's still going to be 2 meters per second squared. And that is going to repeat itself, which means that you now have a straight line, a straight horizontal line on your graph. And that represents your velocity. So now that you have successfully plotted a position time graph and a velocity time graph, we can move on to acceleration. So what is acceleration? Acceleration has to do with velocity. So what is the formula for acceleration? First of all, so acceleration, just like velocity, also has a direction. So what do we have to add above the A? An arrow. So now that we've done this, we can continue with the equation for acceleration. Acceleration is velocity final, and this F over here means final. It isn't a variable, it isn't replaced by a number, it's just indicating that it's the final velocity, minus velocity initial. Again, this I is also like the F. It isn't a variable replaced by anything. It just helps you understand what this I is just like the F, and it helps you understand what velocity you're talking about. And also, you should add the arrow for velocity above, I forgot. So then you divide this by the time final minus time initial. And so basically, now you might be a little confused, but the definition of acceleration is change in velocity. And so all this means is, like, how does velocity change? Since speed is the rate of change, so like how, as you move forward and time passes, what's your rate of change? Acceleration is, as your velocity increases or decreases and time passes, how does it change? So in this case, we can look up here and see our velocity is always the same. It never changes. It always is 2 meters per second north. And if acceleration is change in velocity, then that means that there is no acceleration for this particular graph. Because if acceleration means change in velocity, and there is no change in velocity, then how can there be acceleration? if we're not sure about this, and if we're not sure that it is a straight horizontal line, we can replace these variables with numbers from our graph. So, okay, let's write this again. So what is velocity final? Let's look at this point over here. So what is the velocity final? It's still 2 meters per second. So we can write that down here. Minus the velocity initial. So what's the velocity initial? It can be this point over here. And it's also 2 meters per second. And it's also 2 meters per second. Which means we write 2 meters per second again. Now for time final and time initial. What is the time final? Well, in this case, 40 seconds. And what's the initial? 0 seconds. So we can write that here. 40 seconds minus 0 seconds. And now we can do math. So what is 2 meters per second minus 2 meters per second? Well, this is like saying if you have 5 apples, and then someone takes away your 5 apples, what do you have? You have nothing. So 0 meters per second over, and so 40 seconds minus 0 seconds, that would be if you have 5 apples and no one takes any apples from you, what do you have? Well, you have the same number of apples that you started with, which means 40 seconds in this case, since we're not talking about apples. And so what do we know about any number divided by 0, or 0 divided by any number? We know that it equals to 0. And so if we were to divide this, since we have meters per second divided by second, we would get meters per second squared, which means meters divided by seconds times seconds. And so this is our acceleration in this case. It means there is no acceleration, and it proves the point we made previously. So now we can analyze velocity time graphs with more depth to analyze positive velocities, negative velocities, and all of those types of motion. So let's draw a velocity time graph over here. And we can label it meters per second just to make it easier. And this is time in seconds. So now, what are we going to do? Well, we can just make up a story, and so let's mark the graph however we want to. Okay, so now, let's imagine that someone starts at 0 meters per second. Their velocity is 0 meters per second at 0 seconds. They have no velocity. Now, we can look, for example, at 1 second. What do we want the velocity to be then? Let's imagine it's 1 meter per second. And then at 2 seconds, imagine the velocity is 3 meters per second. And then at 3 seconds, the velocity is 5 meters per second. And so it kind of does the... And then at 3 seconds, let's imagine it's 6 seconds. And so the line kind of goes like this. And so the line kind of goes like... Let's imagine at 3 seconds, the velocity is 6 meters per second. And so if we were to draw a line, it would go something like this. I'm not really good at drawing lines, but if I were better at it, this would look more like a curved line. And so anytime we see a curved line on a velocity time graph, we know that there is acceleration. Why? Well, because, like we said, acceleration is change in velocity. And as we can see, velocity is changing. It would only not change if there were a straight line. But since the line since the velocity increases, in this case, then there has to be acceleration. So what can we tell about this particular graph? Well, we know that this movement, this motion of an object, is plotted above the x-axis, and not below. This means the velocity is positive. As we can see the numbers here, 1, 2, 3, they're not negative. Below, it would be -1, -2, -2, -3, -4, and so on. And just one more thing. We never plot graphs like in math. We might plot them with all 4 quadrants, but we never do that in physics because this x-axis is about time, right? And this one, the y-axis, is about velocity. You can have a negative velocity, which means you're going backward or left or in the opposite direction of what you consider positive, I guess. But you can't have negative time. It wouldn't make sense to have -1 second. And so this part is never used in graphs, only these 2 quadrants. So what can we tell? Like I said, it's above the x-axis, which means it is positive. And what can we tell based on the fact that it's a curved line? Well, based on the fact that it's a curved line, we know that the velocity based on the fact that it is a curved line and that it is curving upward and getting like straighter up, based on the fact that the line is curving and it's going upward and getting more vertical as the slope is getting closer to undefined. So based on the fact that the line is curving and it's going upward, and so the slope is increasing a lot, we know that this graph demonstrates an object whose velocity is not only positive, but increasing. This is because, imagine this is 0 seconds, this is 1, and this is 2. From 0 to 1 second, there's only a slight increase in height of the graph line, let's say. And then from 1 to 2 seconds, from 1 to 2 seconds, there's a much bigger increase. And if we were to continue, it would be such a high increase that it would continue to get even higher. It might not even pass 3 seconds, this line over here. And so as time is getting shorter, but this means that the object is going faster because it takes less time to go at a higher velocity. And we can also tell because of this because of the acceleration. Because we can also say this because of the acceleration, since we know that there is acceleration. But how do we know if it's positive or negative? Well, we can determine that by using the same formula we used above. So, this is the formula for acceleration, in case you need to remember. And so, in this graph, let's use this point and then this point. So, what can we tell? Well, in this case, since the graph has a curved line, determining acceleration would be very hard. But let's imagine for a second that it's a straight line. So let's forget that it's a curved line. It's still going up. So the line is still going up, though it isn't really getting steeper, but there is still acceleration. So if we go down here and we do the formula for acceleration, which is velocity final minus velocity initial divided by time final minus time initial, and then we can replace this. So let's look at this point and then this point. So this lines up with 3 and with 6. So this is the final velocity. Let's say, imagine the graph ends over here. This would be the final velocity. And what is it? 6 meters per second. So we can write 6 meters per second minus